here, we know, yeah, we just know the string relationship, right? And we already know the material mechanism. For string, they equal to, right? They equal to the stress to divide the modulus, right? Modulus. So for this one, this is the concrete. The concrete plus here we have this formula, but do not sure, right? Now we do not sure what this symbol represent. Let's go back to analyze. Yeah, analyze. And for here, we can think, yeah, this is the shrinkage caused by the concrete, right? Concrete is shrinkage. And for here, we can think for this is the steel bar, they already be there. After the shrinkage, they enlarge. Wait, finish. Yeah, look at this figure. Look at these figures, okay? Figures. To compare, this is the totally the shrinkage stream that occurs in the concrete do not have the steel bar, right? But for this one, for this specimen, if this is the totally we have the steel bars in the concrete, but of the cost, the reason of the shrinkage, right? The reason of the shrinkage. This steel bars, if there's no steel bars, the concrete will come to here, right? Come to here. But there has the steel bar. For steel bar, the concrete provide the tension to the steel bar, which I see you noted. Yeah. You understand?
Yeah, I'm following.
Follow what?
I'm following what you're saying.
Yeah, you know, right? In this state, for this specimen, the steel bar is in the tension. Yeah, in tension. Because if there's no steel bar, the concrete will come to here. Come to here. But there has the steel bar for the concrete. For the concrete, they provide tension to the steel bar. Yeah. And for the concrete, they under the compression because the shrinkage will give the force to compression it. Then, so it had these deformations. So here, for the CT, right? CT is the steel bars. They because of the compression, they give the tension. So here is the tension in the steel bars here. Yeah, this one is for the steel, right? This is the compression occurs in the concrete here. This modulus is the concrete.
So I've got a question.
Yeah. Okay, let's discuss that next.
Yeah, I wanted to ask, so for reinforced concrete,
Yeah.
what is just telling me, okay, when you reinforce concrete, does it still maintain the properties of concrete, then you just add on the properties of steel, or do you completely change the...
No, they will depend. We can think the concrete has its own character or property mechanic. They will affect the steel bar. Steel bar will affect, but there beside these two materials, there had a force relationship exists here. But this material is this material. They will do not change this material the property.
So, let's say making reinforced concrete. Do you buy reinforced concrete, or you can easily just make it yourself?
Just to make it.
Yeah, like, do you buy already made reinforced concrete, or you can just make it yourself? Looking at the fact that reinforced concrete is just steel added to
Concrete, right?
Yeah.
Steel and concrete. Yeah, but the bond is together, right? They had the bond force. Like the concrete is like four things. Steel bars inside they had the force to transfer. The concrete can transfer the force to the steel bars. Steel bars, if it had affected by the load and another thing, they also will affect the concrete, right? But for before we know the beam, right? For beam, it's under the load. The bottom we calculate from the material mechanical. They are in the tension, right? The tension force exactly resisted by the steel bar, and in the before the top, they are in the compression. They resist by the concrete, right? Yeah, for this thing. But here's the load. Do not apply the load on the surface of the beam. Just a spaceman. Here's a steel bars. This one, the concrete, they will shrinkage. That means concrete under the shrinkage they had the deformation, but because of the steel bar, they do not shrinkage to his original place. Yeah, there is a little complicated. We need to distinguish. There's a stream relationship, and then follow the formula so we can drive the force. Here, I'm mixed. I'm a little confused. Sorry. That's for now. This step, this figure to these figures, let's together to discuss. Maybe we can get a way to understand these questions. Okay, and yeah, because if there's a no steel bar, right? There's a no steel bar. No steel bar. This one to this one, the reason cost is this string, right? This string caused by the shrinkage. We realize that. We already realized that. But if we put the steel bars in the concrete, they also had a shrinkage. Right? This shrinkage will make back here. This shrinkage gives the force to the steel bar. For this one, I think everyone can understand, right? Because for this one to this one, so the steel bar is under the compression. Do not talk about the concrete. The steel bars under the compression. Yeah, because his original length is here to here, right? But because of the force, they go back. They go back. They deform. So how to make a material the length is small? That's we give the compression to the material. So here, the steel bar is under the compression. But for the concrete, if there's a no steel bar, shrinkage will cause this deformation. But because of the steel bars exist in here, they give the force to the concrete. So the concrete compared with before, we need before this one. So the concrete is under tension. Because here, so we need to compare this one to this one. There's a no steel bars. That means concrete is freely, right? They are free. They also the shrinkage they will come to here. But because of the steel bars exist in the concrete, so the deformation they changed. The concrete is tensioned. The length is larger. We need to compare this one to this one. The concrete. So the concrete is in tension. Right? Now we can clearly to realize the string. This string for this value, right, is the before the Zhang Heli, what Zhang Heli said is correct. Yeah, we needed to know the meaning. Yeah, to know the meaning of this one, the symbols here. So here, this one is caused by concrete tension. So, and this one is the steel bars compression. Yeah. Here, know the meaning. This one is the concrete tension. And this one is the steel bar compression. So we get the first character here. Yeah. Concrete is in tension, and the steel bars is in compression. Yeah, okay, that's right. Here, know exactly the meaning of the string here. So at here in the stress of the concrete, the tension stress. Here we need the modulus of the concrete.
So
yeah.
So concrete is stronger in convection or
concrete is in tension. Yeah. Concrete, of course. If there's no steel bar, right? no steel bar, the shrinkage cost, it will have this deformation here. Yeah. For this one, we know, right? So compare this one to this one, we found the concrete be larger in the length direction, right? Because of the steel bars provide a restrict to the concrete. Okay, point?
Yes.
So I will ask you, what the state of the steel bar? The steel bars in here is the compression or in the tension.
Scuba resist the shear force.
Uh-huh.
Resist the shear force, right?
Shear force,
Yes.
not shear force, just the tension or compression.
Compression.
The steel bars in compression.
Yes.
Why? Can you explain? Can you say something? The reason?
So I can explain that.
Okay. Doesn't matter. I will say it again. Okay. Everybody, focus. Attention, please. Listen to me. Here, really, if you do not care, you will miss it. Yeah. For a spaceman, right? There is a fresh concrete. This is the plain concrete, right? Plain concrete. Do not have the steel bar. For this one is the RC, reinforced concrete. They have the steel bar. We use a mold to get this true specimen, right? But for the fresh concrete and the reinforced concrete, they will have the shrinkage, right? This shrinkage, they curve like here. This one is the CS. There's a no steel bar. Of course, it will have the shrinkage because the string to the specimen. Right? This one is easy to understand, right? Yeah. And for the reinforced concrete, of course, it's affected by the shrinkage. They have the string, right? They have the string. What we can realize here is the steel bar reduced compared with this one. So the steel bar is in compression, right? Right? And for concrete, right? For concrete, they are larger, they increase. Because if there's no steel bar, after shrinkage, the concrete will be there, right? Yeah. Will be there. But it's affected by the steel bars, the length of the concrete be larger. So that means the concrete is in tension. Right? Yeah. I think someone can get the point. They underline.
What a question.
Oh, it's understand.
What condition is that? Are we applying a force or just letting it dry out?
We do not apply any force to the specimen. Here, only the shrinkage happened to the specimen. They occurred the stress. They occurred the force
So
in that.
Doesn't shrinkage,
Yeah.
rather,
Another
I remember you used hydration.
hydration.
That's different. I saw hydration in the previous.
Yeah.
Yeah. So looking at hydration, doesn't that only take place with concrete?
You mean the hydration do not only happen in the concrete?
No, I mean since right now there are two materials, there's steel and concrete.
this one is a plain concrete. They have no steel bar.
I'm not talking about that one. I'm talking about the last one.
Last one, this one, this one.
Yeah.
This one, of course, the concrete they had the shrinkage, right? The steel bar, you know, steel bar is a metal. They do not happen hydration.
That's
Uh.
that's what I'm trying to say. Because if this one is reducing,
This
how
one,
come in the previous? How come, like, let's say in the after, it's from there to there, right?
there
Yeah,
to there.
Yeah. It's like there it looks like all of it got shrunk. But looking at the fact that steel doesn't shrink as
Uh-huh.
concrete.
Oh, this one just observed in the experiment because steel bars is stiffer, strong. It's strong than the concrete, right? Yeah. If you think, I know what you mean. You mean why the reinforced concrete they happen to here? Why not happen to like be there, right?
No, that's not it. You mean like,
So when she
why
was
also the steel bar?
Why is it also? It looks like it also shrunk.
Yeah, the
Yeah,
steel bar.
because it's under compression.
compare.
Yes, yeah, why the steel bar is also compressed?
Compressed.
Yeah.
Compressed because here, okay. Here you may do not know the bond force between the steel bars with the concrete, right? Steel bars in concrete, the surface, they touch the concrete. They had the friction or another bond force, right? They bonded together, like you tie the steel bars with the concrete. Like yeah, you just think the bond between the concrete and the steel bar, they are very tightly. They can together to resist force. So that means they have a strong bond. Yeah. So come to here. They have the same deformation. That means like the steel bars will already be there. The concrete they shrinkage itself do not affect the steel bar. Yeah. Your meaning, right? Your meaning is that? No. You can't think. You can't regard the reinforcement like this. They proposed here. They are belong to earth things. They will deformation together. They can change the size, or they will be together. Do not means it will do not change, and only the concrete change. Yeah. Okay.
Before, let's see that experiment, right? The one you showed us. Let's say we're applying a force here,
Yeah.
and this is reinforced.
Yeah.
Yeah, we know this one just going to bend inside, making it, resistant to, those cracks and whatnot. But in this state, like right now,
Yeah.
you're saying it's about shrinkage, not about no force. This is not there. So meaning, when you draw this thing, this is reducing, looking at this, which factors again, shrinkage, the hydration and whatnot. So if you put in the
Steel bar. Yeah.
me, I was expecting maybe something like this, but the steel bar still remains like this, because if the steel bar shrinks the same way the concrete shrinks, like that's my confusion, because this is quite different material. Because the drawing is from here, see, from here to when you see the one which has been shrunk, and that means that this is the one like it has reduced from here. That's one issue. Like, from here, the concrete which like this cover. This one looks like it's the one that we will take this now. No, my question was, Also, this one is also strong. The same way strong.
Yeah, they are two material, but the mechanical they are near. So under the load, they work together. They work together. Do not like what you mentioned. This concrete, they will look like this. Look like this. This means this member, this root, they had the large crack will around the means, right? Here, the bond force will cause the concrete and the steel bar, they together, under the load, they will have the same deformation. Okay? Ready? That doesn't matter. So if after class we can to do the further talk about these things. But yeah, I know when he said they're curious about the why the steel bar and the concrete can work together. They had the same, the deformation will look like this, right? So, but at here, we know there's a bond force around the surface of the steel bars and the concrete here. So they must work together. If the steel bars do not work together, means they had a big crack developed between the steel bar, developed in the concrete, reinforced concrete. That means this reinforced concrete is broke. And okay, so come to here, I think someone can understand, right? Understand why the concrete is in tension and for the steel bars, they are compression. Okay, for the Wenqi's question, we can discuss later. But for here, for the content show here, for the formula list here, they have this meaning. Okay, this meaning. So these symbols. Yeah, we can build this relationship, right? And for here, we can obtain, this is the stress, right? Stress divide the modulus, and this is the stress. This is the steel modulus. Steel bars modulus. This is the concrete modulus, right? For here, this modular is a constant. Right? This is the stress. Stress divide modulus, elastic modulus can get strain. This one we already know, right? This one we already know. Yeah, and for this sentence, for this formulas, it means in this section, the tension force is equal to the concrete compression force. This one can someone understand? Is the Newton's third principle. Because for the steel bars, tension is provided by the concrete, right? Concrete provide the steel bars tension because for here, and for the concrete tension is provided by steel bar, and for the steel bars, compression is caused by the concrete, because the force around the steel bars here, they are just concrete applied load to the steel bar, and the steel bar provide restrict to the concrete. Here has the force. The absolutely value is the C. Absolutely the value is the C. And for the force, we know it's the area multiply the stress, right? This is the steel, and this is the concrete. This is the concrete. Concrete is in tension. So the sigma CT, we just transport the formula AX sigma SC divide AC, right? So in here, the area is the concrete, the section area, and the steel bar area is the area of the steel bars. So use this formula, substitute in here. Yeah, and this sentence, yeah, these formulas we can get. Okay. Yeah, if we know the relation about the steel bars modulus and the concrete modulus, this material, the shrinkage stream and the concrete, the steel bars compressions, we can calculate from before the formulas we dropped here. Here, the hard point, the key problem is that we understand this formula, and this formula. This is the original formulas. Other formulas we can derive from these two basic formulas here. Yeah, I this here, this one. This formula. And this formula. Yeah, this two basic formula we can transfer that and substitute, and the final the shrinkage, the stream of the shrinkage cost in concrete, right? Concrete here. This one we can calculate. Yeah, okay, this is the homework, okay? Homework will help you to strengthen to the what we learned today, this formula. And they have the values. I hope everyone to do the calculation to understand, to realize, okay? And yeah, calculate the stress in reinforcement, and the stress in concrete. That means we need from this value, right? This value. To calculate the stress, steel is in compression, concrete is in tension, right? To calculate these two values. Okay, this one homework, I hope everyone writes in a paper. The papers have your ID, your name, and then submit to me before. The next class, next week, theme today, you need to submit to me. And for the student have the class online, they need to send the digital version to me in email. Okay? Yeah, I will see it again in our group. And yeah, just to use this example to practice. Okay, I think today the class content may be enough for you. And okay, if you still had this part question, do not clear about the string relationship. Yeah. You can remember this formula and then bring this formula to understand, to see the figures and maybe get the point. And if you still confused, okay, can't ask me, because I have to say, listen, the English may not easy in practice. We practice speak English, but that matter. Just again and again, I can get your point and to explain that to you. Yeah. Do not feel maybe shy or another things that think ask a question is stupid. Do not mean that. Ask a question means you are curious about content. You are thinking what we learned. So that matters. That matters if you still have a question. This is the yeah. Also the thing, right? I can explain something. The member, right? 1% means the area for concrete, right? The area. Like the section of it's a rectangular, the steel bars. The steel bars area divide the concrete is 1%, right? 1%. So we can from here we can build. Okay, we can build this relationship, right? This relationship. And the concrete, the shrinkage, free shrinkage string. Free shrinkage string means the totally, right? The concrete free shrinkage string we can get. And for the steel bars modulus and the concrete modulus, yeah, this two is the constant because for material they will do not change with the temperature. They will do not affected by the force. Right? But here we can directly to use these two values in the formula. So go back to read this one. We know the free shrinkage of concrete and the modulus of the concrete, modulus of the steel bars. These values we do not know, right? And we have another formulas for this one, AC and ES, the area we already know. So the stress of the compression stress in concrete and the compression in steel bars and for the concrete in tension. Yeah, so according to these two formulas, and we can get, right? We can get. Yeah, okay. For this homework, right? This homework need you to write in the paper and submit to me. Okay, and there is the next we will talk about the free. Okay, so today's class is over. Can you read here and talk with me about your questions? Come. Yes. What's your main point that also your question that you need for steel bar, for concrete, for reinforced concrete, it means during the shrinkage, the steel bar will not shrink. Still, yeah. But exactly, you know, here we just simplify all use a line to represent the steel bar. But exactly for concrete, right? Concrete, the steel bar they have its own size, and here they are not smooth. This smooth, this roughly the surface, they will they will have the action with the concrete. This one you can understand, right? Yeah, you can look at the here. The steel bars will look like this, and the concrete. They have the bond together. Right? If the steel bars inside, they had a rough friction of concrete. So we think they work together. They had under the load, under the action, they can work together. They have the seam deformation. If you think the concrete had its own deformation, the steel bar has its own deformation. That means these two materials do not have the action together, do not have the effect together. Right? So at here, just of the concrete do not float. Steel bar and concrete under the load, under the temperature and another environment action, they work together. They have the same deformation. The shrinkage here, I drew in blackboard, they made large. But exactly, it's really small. I just to draw here is a large. You think, oh, it's a can. It can't be like the steel bar and concrete has this large deformation. But exactly, it happened in reality. This deformation is really, really small. Do not have a joke here like the B. So it works together, everything. Understand? Okay. So you can finish the homework now. The next class I will ask you to come blackboard to explain the homework to us. Can you promise me to do this one?
Yeah, don't make progress, of course.
Okay.